So I am creating a new project. Give it any name. In TIA portal, once you are in the interface looks like this. We will go to add new device. And in the device, I will try to find exactly what I have here. And if you see any PLC like any other device or hardware, there is a serial number. And with that serial number, we can search it. If I can find this one. So it is 6ES7 214. Yes, so it is exactly this one, 6ES7 214. And yes, so I click OK, and then we have exactly this PLC. And then we will go to program blocks, main, and then at the same time we need the connector between TIA portal and factory IO. And for that we need to initiate an other instance of TIA portal. You have version 19, all of you. Okay, that is fine. You have worked with factory IO before. Okay.
But I didn't realize in myself. I knew that we
Okay. Okay. Yeah. So in this case, we need to open the file that you that I have sent to you. So just open that file. So once you have opened it, you can go to this PLC programming, this tab, PLC programming, click on this function block, right click on it, copy, and then go back to your original instance of TIA portal where you are going to write your program. Click on main, right click, and then paste. And then you will see this function block over here. After you have pasted it, then you can close this instance from where the function block has been copied. So that's it. Okay, then I have provided you these 2 pages, and here you can see the scenario that we need to create. Basically, when we write a program in PLC, we need to specify the addresses in the form of bits and bytes, like zeros and ones, when a signal is turned on and when it is turned off. So there are 7 tags that we need to create, and you can see that there is a start tag, then reset tag, a start push button, reset push button, and these both are input tags. And then there are 5 output tags which with the symbol Q. So we need to create all these 7 tags, and then we will write the program. So let's start creating the PLC tags. For that, in the PLC device, you can see a folder with PLC tags. Expand it and then show all tags. PLC that I am using is, you don't need to exactly use this one, but it is a good idea to just try to search a specific device that you have. 214 1BG 31 0X B0. You can also change a PLC as well. For example, if you have used another one, but later you want to change its program for a different PLC, just right click on it and change device, and then you are able to exchange it with another hardware. Okay, so then in the show all tags, I will create all these 7 tags. For example, start, push button, reset, push button, and these both are with you can change your address by clicking over here, and then you can identify the address and the bit number. So for these ones, I00 and I01, these are input signals, and then we have 5 output signals, and they are conveyor. It is a good idea to change it to your required one. So if I change it to Q, then all the next ones will automatically be Q signals. So Q00, start indicator, reset indicator, and remove one. So these are 7 tags that we will use in our code or program. Once you have created all these 7 tags, then we'll move to the next step. The data type is Boolean for all of these 7 tags, and 2 are input signals and 5 are output signals or tags. And then I will return back to my main block where I need to create a program. So these are network 1. It is network 1. I will need to create 4 networks, and for each of one you have been provided with a diagram in the pages that I have given to you today. So the people online, maybe you are not able to see the pages, the 2 papers that I have provided, but they will be available on Moodle soon after the class. They are basically showing the network diagram that we will be creating in this TIA portal code. So as you can see on the paper, the first network only contains a block, an interface to the function block, and for that we will just create this empty box. And once you have created this empty box, write the same name as you have for this function block. And this function block has a name of FC9000. So once you write this name, enter, and it will connect itself automatically to this complete function block. So for the first network, we only need to write this. So this is basically just creating a communication between, or in other words, it is providing an interface from TIA portal to the simulation program that we are using, which is Factory IO. For plant simulation, you don't need to create any such function blocks. Plant simulation has more easier or simpler connectivity. So we will be able to, we will do plant simulation connectivity, and then you will see that it is even more simpler. Okay, and then for the next one, we need to create a scenario where we need to create this normally open, and for each of them we need to write the name of the tag that we have created. You can either write the name of the tag, or you can type the address for that tag And in this case, it is M00 start button, start push button. And then we will write and M00. It is another tag to record, to store a memory or to store condition of a signal. And then we will connect it back to this network. And here we need to create a normally closed reset push button. And then we will again use this memory tag that we just created. So basically that, sorry.
How do you create the memory tag?
Just click there and then select from here.
How do you assign this memory?
Okay. I repeat this step. So select this bar, this vertical bar, and then this one, open branch. So once you are at open branch, it will create an open branch, and then select normally open. And here you can assign a memory tag M00. And with this connector, the connector that you are seeing here, if you click it and drag and connect it with this one, so it will get connected. Then normally closed I0.1. And then again, we will assign this memory tag, which is output for this network M00. So basically this is just start stop logic, and it ends here. And then we have network 3, which is about turning on all the devices that we will have, or all the actuators that we will have in our simulation. And for that, I have again normally open, which is M00. From here it will start, and then the outputs are Q00, then Q0.1, are all of you are taking more than one course in this semester? Okay. And how do you compare the workload in this course with other course? Is it less workload or comparable or more? Or... Okay. Right. And how and is it aligned with your expectations? I mean, do you expect more workload, or do you expect lesser? It is manageable. Right, and then finally for the network 4, we have normally closed the same tag M00, and then a reset indicator, which is Q0.2. So basically, this is all. This is our program to control the simulation that we want to control. Okay, at this point, okay, maybe before compilation of this code, let's create the simulation that we want to have. And in Factory IO, I hope you all have Factory IO in your computers. You need to start the software, and in factory. The reason why I'm using it and not plant simulation, so plant simulation and process simulate, we are basically using those two tools. But since they are bigger tools and they have more functionality, or they may offer a little more complexity in the beginning. So just to understand your code, that how this interfacing works, I think Factory IO is quite simple tool to start with. But we are not going to use Factory IO for our simulations, etc. It is just to start understanding how this interfacing works, and then we will move to our original simulation, which is technomatics, plant and process simulations. So in this case, this is how its interface looks like. It is quite simple, very simple. If you can type here a conveyor, and we are using this large conveyor, 6 meters conveyor. And then we need a start button. I'm just dragging and dropping these buttons. And another reset button. And then you can move these buttons next to conveyor. If you just select the object and move your cursor, you can see that you can move them on X and Y plane. If you move them vertically, if you need to move them vertically, then just select the device and hold down V, letter V on your keyboard, and then you can move it upwards. Similarly, this start stop button. So basically, you can see that the software understands where there is an object. For example, you cannot move this button beyond the conveyor, so it knows that there is some object and it is creating an interference zone. Okay, so we have placed this start button and reset button next to the conveyor. Then we need an emitter. Emitter is an object that will create parts that will be moved over the conveyor. So move it over here, and from here it will generate objects. And then we need an exit. You need to place it exactly on the conveyor, then it will delete the objects. It's a very similar function as the drain in plant simulation. Okay, at this stage, if you start the simulation, you can see that it is creating these pallets, and on pallets there are some boxes. You can change it by right-clicking on the emitter. Has any one of you used or seen a simulation program? Its name is Visual Components. Okay, Visual Components is also, I like it very much. It is a big tool. It can do simulations. It can do robotic simulation, throughput simulations. And it also works very similar to like this software drag and drop functionality. But of course, it is quite big tool as compared to Factory IO. Visual Components. It is a Finnish company, Finland-based company that developed it. Okay, so our simulation is completed. It is a very simple simulation of a conveyor. If you want to change what objects this conveyor should, or this emitter should generate, you can right click on it, and here you can see what it is generating. So it is basically generating base to emit. For now it is palette. Maybe I don't need any base. And then part to emit. It is emitting 3 different sizes of boxes. Box, large, medium, small, you can select any other thing. And stop it. So basically that's it. This is our simulation that we want to control. And if you run the simulation now, you can see that it is generating object, but the conveyor is not starting up. It is still stopped. And then we will return back to our program that we are writing in TIA portal. Before compiling it, one thing is that start with compiling this function block, right click on it, compile software. And in this area, you will be able to see if there are any problems or errors. And here you can see that there are no errors. So it is all good. Then we will compile the complete PLC, right click on it, compile hardware and software, and okay, so there is no problem. It has not shown any problem. So hopefully it will work. And if there is no problem, then at this step, before downloading it, you need to start the emulator of PLC.
About password and stuff.
Okay.
Because so we have to.
Then, so if you are getting password, then do it with one by one. Yes. Sometimes it is depending on the model of the PLC. Sometimes it requires a password. But do remember the password because when downloading it, it will ask. So if it has given password error, so there will be two places where you need to enter password.
Yeah, so there's still two other areas.
Yeah, so try to compile it again and then it will specify you exactly where to enter another path. Start PLC sim, which is an emulation of PLC. Right click on your project in the project tree, properties, and in the protection, select this option, sports simulation during block compilation.
Where is it? What's that for?
Okay, and then in the PLC sim, let's connect. You need to create a workspace, give it a name, then select this tab. I already have a 1200 PLC added. You can add from on the right side, you can see you can add any PLC that you want. Then start it, and it should appear as yellow, and then download the program. So I have created a new instance in PLC sim, and then it seems that it has downloaded. And in this case, now I think it has been downloaded, and then if so, Srinath, I was just telling that in my case, I was facing some problem in downloading the program to virtual PLC or PLC emulator. But one reason could be that I was working with a physical PLC just before the class. Maybe it changed some settings. So now I have created a new instance of PLC in PLC sim, and I have restarted my computer, and then I am able to download the program. And this time it didn't give any error. So, and then if I just go online, so all the indicators are green, and it means it is working fine. And then if you want to monitor your program, you can click monitoring on off, this small glasses icon with green play button. If I click this one, so it will. Okay, so why it is gray? Because I have not started PLC. So start it. And now you can see that the signal is activated. So now we should be able to start our conveyor. For example, now if I am starting the conveyor, the objects are still placed over there. Right click on it. There can be different ways of turning a button or a trigger on off. So modify to 1, and now it is on, and you should be able. Okay, so we haven't created a connection between factory IO and PLC sim. So that is the last step that we need to perform. Move to factory IO, and we need to make an interface. So go to File, Drivers, and in the drivers, you need to select the PLC. So if you have physical PLC, then you will select that one, for example, 1200 or logo. Since we are using PLC sim, so the last one is PLC sim, Siemens S7 PLC sim. At the same time, we don't need that many. It is okay if you leave them like this, but if you want to change the configuration on the right side, you can see this configuration. So yeah, make sure that model is selected here as 1200, the one that we are using. And I need input signal to right.
Okay.
Yes, so on the right side. So I have 2 input signals and 5 output signals. That's it. And then I need to connect these input and output signals. So on the right side, you are seeing input signals, and on the left side are all actuators or output things. So drag and drop start button to this one, I00, reset button to this one. I have specified this sequence in the paper that I have given to you, and it will be available at Moodle as well. So the sequence is also there. In the driver window. Yes, sure. Fine.
Okay, yeah, so, oh, I see, okay, so I just typed the technology into the gluing into the, let's say, put it in the outside side.
Right.
Okay.
And yeah, so I will connect. Okay, they have been connected, and then I need to connect belt conveyor first, then start button, then reset button, ammeter, and remover. So once they have been connected, the last step and the most important step is to click on this connect. And if you connect, let's see. Yes, so it got connected. So here on the left side, you can see this green tick mark, which shows that it has been connected. So now if we go back to conveyor, since our PLC has already been activated, if I start it, you can see that the conveyor should be working.